Hello friends, welcome to Suresh Aggarwal's Mathematics Shortcuts. In my last 2 or 3 videos, I have been taking up special concepts which are given in the new NCERT textbook, and this is the chapter on number play. A beautifully crafted chapter, and if you go deep into each and every subtopics which are given in the chapter, you will find lots and lots of very interesting patterns and special numbers. One of them are the palindromic numbers. You know palindromic numbers like 1, 2, 3, 2, 1. They read the same from the left to right and from the right to left. So I have already put 2 videos in which I told you how these palindromic numbers have such beautiful properties. And in this video, I am going to take up one more very super interesting concept, and that concept is that of the reverse and add. This is the term reverse and add palindromic numbers. This is a special method through which we obtain the palindromic numbers, and this is one of those exclusive videos which does not exist on YouTube as of now. A lot of research has gone into bringing out these concepts and then videographing and putting it in front of you. So you need to watch the complete video. You need to share it with all the mathematics teachers who are teaching in CBSE schools, and all those lovely students of class 5, 6, 7, they are going to enjoy this video. So before I start this video on how to obtain the palindromic numbers using this reverse and add strategy, let me tell you about one of the very important things, that is the short tricks ebook which we have very recently launched, and this is specially for quantitative aptitude and reasoning. This combo is so useful whether you are a school student or a college student or anybody preparing for some government competitive exam. Reasoning and quantitative aptitude, you can't escape those topics, right? So this ebook aims at helping the students clear the bank PO, the CTET, the NTSC, MBA entrances, and then MAT, the PRMO, LIC, then all of the various Olympiads like IMO. All these exams become so easy when you study through this quantitative aptitude ebook and the reasoning course combo. So you can see the features: 24 chapters in this ebook of quantitative aptitude, 18 chapters in this reasoning course. This combo will help you calculate 10x faster and has over 300 short tricks to crack the multiple choice questions just by watching the question. How to get a copy of this? WhatsApp 9896 369963. That is the number, and the same number you find in the description of this video also. So friends, let's see the wonderful world of palindromic numbers. Why do we call it reverse and add? Now for this, let me take a very simple concept wherein I am choosing any 2-digit number. Starting from 10 to 99, you can choose any number. Let's say the number is, how to start, 84. Let's take 84. So 84, if I start with 84, reverse and add. So 84 has 2 different digits, so it is not a palindromic number, right? If I reverse this, it will become 48, and if I write 48 under this and add, this will become 2, 1 carry means 132. Now 132 obviously is not a palindromic number again. So what I have to do is to do this reverse and add technique once more and check whether I obtain a palindromic number or not. So 132, the other way around, it becomes 231, and now if you add them, you get 3, 6 and a 3, and there we go. 363 actually is a palindromic number, because if you read it from the left to right or from the right to left, it becomes a palindromic number. Now does everything work like this? For every 2-digit number, is the rule same? Do we have to reverse 2 times and then get the palindromic number? It does seem so easy, right? But there are so many technical things in palindromic numbers. Like you have a doublet. suppose 33. Now 33 itself is a palindromic number. So if you read it from the left to right, you are going to get 33 only. And if you take the reverse, there is no use of taking the reverse, because it is again 33, and adding 33 to 33 will give you another doublet only. But what will happen if the number is maybe more than 50? Now let's check what happens with that doublet. Okay, so suppose you have a number like 55. Now 55 and reverse of 55 is another 55. Now when you add them, you get 110, and this is not a palindromic number. It reads 011 when you read it the other way around. So what is the rule? There are so many different things to learn. So if you take the other way around, it is 011, and now if you add it, you get 121, which again is a palindromic number. So does it work like this every time? The purpose of this slide was to tell you what is the reverse and add palindromic numbers. Now let's go deep dive into this particular concept. Here we have the digit sum. Now I am going to try to link these palindromic numbers by the digit sum of the two-digit number. So digit sum of two-digit numbers and palindromic numbers. How are these two things interrelated? So let us start with, a digit sum can be minimum 2, because 1 plus 1 is 2. Like for 11, the digit sum is 1 plus 1, that is 2. We can't have a digit sum less than 2, right? Except 10. 10 obviously has digit sum 1. Only 10 has digit sum 1. And then 11 has digit sum 2. And then it can be 3, 4, 5, 6, 7, 8, 9, 10 up to 18, because the highest number is 99. So 9 plus 9 is 18. So the digit sum starts with 1 and goes up to 18. Now see what happens when the digit sum of the two-digit number is 9 or less. So let's take some numbers where the digit sum is 9 or less. Suppose we are talking about 35. Now 35 has digit sum 3 plus 5 equal to 8, right? And see what happens. You are going to obtain a palindromic number in a single step of reverse and add. 35, the reverse is 53. Now if you add them, you get a doublet, which is 88, and there we go. It is a palindromic number. 88 is like 88 only when you read it from the other way around. And so this will happen till we obtain the digit sum of this number as 9 or less than 9. You can check any number. Suppose I take 14. 14 is 1 plus 4, 5. So digit sum is less than 9. Reverse is 41. And you add them, you get the doublet 55, which is a palindrome. You can take digit sum 9 also and check. Maybe how about 27? 27 has 2 plus 7, 9 as the digit sum. So 72. Add them, you get 99. So you are always going to get a doublet when the digit sum is 9 or less. Now what happens when the digit sum becomes more than 9? That's where we need to analyze the situations. We need to take lots of examples of digit sum 10, then digit sum 11, then digit sum 12, 13, 14, 15, up to maybe 18. Now, if I take one example of having a digit sum, say, how about taking 13 as the digit sum? If I take digit sum as 13, which number has digit sum 13? Is it like 58? 5 plus 8 is 13. Now let us check the add and reverse or reverse and add strategy. Does it work on 58? The reverse is 85. Now when you add them, 8 plus 5, 13, 3, 1 carry. 8 plus 5, 13 plus 1, 14, 143 is not a palindrome number. See, unlike here, when the digit sum is more than 9, it doesn't work in one step. And what happens next? Can we continue this reverse and add strategy? 341. Now if I add them, 4, 8, 4, and there we go, it's a palindrome, 484. So for digit sum 13, we have to do 1, 2 steps. And likewise, if you increase the digit sum, suppose the digit sum becomes 16. Now we can have some numbers where the digit sum is more than, even you can take 14, 15, whatever you want to, because in the next slide I am going to summarize it. Okay, so let's see, 15, digit sum 15. Which numbers have digit sum 15? 6, 9, we can take that. 7, 8, we can take 7, 8. Let's take 6, 9. 6, 9 is not a palindrome. Reverse it, add it, you get 5, 1 carry. 16, not a palindrome again. 5, 6, 1, reverse and add, you get 6. Then we have a 2, 1 carry. 7, again not a palindrome. Can we do it once more? 6, 2, 7. Do we get it now? 6 plus 7, 13, 3, 1 carry. We have a 5, and 7 plus 6, 13. Still no palindrome. 1, 3, 5, 3. Can we do it once more? 3, 5, 3, 1. Try now. We get 4, 8, 8, 4. See, is it a palindrome? It does, right? Because 4, 8, 8, 4 from the left to right and 4, 8, 8, 4 from the right to left. It works. But does it work for all numbers having digit sum 15? I checked it and it does work. And ultimately you will get to this palindromic number only when the digit sum is 15. Try it with some more numbers. So how many steps? 1, 2, 3, 4 steps, and it gets me to a palindromic number. So I have a summary. You can check this. Digit sum is less than or equal to 9. The number of steps required to get to a palindromic number is just 1. In one step, reverse and add, you get the palindromic number. Palindrome so obtained will be a doublet. As I already told you, like 23, 2 plus 3, 5, digit sum is less than 9. So 23 plus 32 gives a doublet 55 and it's a palindromic number. Likewise, if the digit sum is 10, if digit sum is 10, you require 2 steps to get to a palindrome, and the palindrome will be 121. Can we check? Let's take 46. 46 plus 64 is 110. 011 is the reverse, 121. There we go. See, palindrome number and 2 steps required. Likewise, if the digit sum is 11, 1 step will get you the palindromic number, which is again 121. You can check it using the number 92. If the digit sum is 12, you require 2 steps and the palindrome you will obtain is 363. Let's check it with 84 plus 48 gives 2, 1 carry, 13, and then 231. Now look at this. We have a palindrome 363. Here we have mentioned this here. Likewise, if the digit sum is 13, you require 2 steps to get to a palindrome, and the palindrome obtained will be 484. You can check it with 58. 58 plus 85 is 3, 1 carry, 143. Then 341, you get 484, which is a palindrome mentioned here. Likewise, digit sum 14, 3 steps required, and you will get to 1111. Just try reverse and add, reverse and add, reverse and add 3 times. Take the number 68. Let me know in the comments whether it works or not. This rule you will not find anywhere. This table is freshly made and exclusive thing for all of you. Likewise, digit sum 15, I took one example very recently in my previous slide. 4 steps required, you will get to 4884, and try it with 96. 4 steps will get you 4884. And likewise, I tried digit sum 16, like 79 has 7 plus 9, 16. Try it with 79. You will require 5 steps of reverse and add, reverse and add, reverse and add, reverse and add, reverse and add 5 times. You will get this number 44044, which is a palindrome. Isn't that amazing, friends? The world of numbers, how you explore, how you deep dive into the number system and get all those beautiful facts about numbers. So friends, if you like this video, do share it with all your friends who are in class 5, 6, 7 looking to build up that mathematical aptitude. If you are a school teacher, please watch this video. Please make your students watch this video in the school so that they can understand how to develop that number sense, how to understand how to get these palindromic numbers using the digit sum, the relationship between the two, and that will develop a very good mathematical aptitude in the students. Do like this video, and as soon as you click the like button of the video, you will see an option of hyping the video. You can award points to the video so that it comes in the feed for other students also, and they can also take advantage of this amazing video. Thanks for watching this video, friends, and all the best for the practice part of palindromic numbers.